Now it's time for us to look at the expansion techniques. We will first look at distributive law. The distributive law states that a plus b multiplied by x plus y would give us ax plus ay plus bx plus by. This is how it's come about. Firstly, we will multiply a with x, then we will multiply a with y. After that, we will multiply b with x, and then b with y. This gives us the four variables ax, ay, bx, and by. Let's learn how to apply this law. Take a look at this example. We have to multiply 2x plus 3 with x minus 4. The expansion would give us 2x squared plus 3x minus 8x minus 12 when we make use of the distributive law. Then we will combine the like terms 3x and minus 8x to obtain minus 5x. This is the simplified version. It's now your turn to try. Pause the video and attempt these two questions. Once you are done, play the video and check your answers. Check your answers. Did you manage to get them right? Make sure you give the simplified version of each expression. Let's now take a look at a different expansion technique. How would you expand the square of a plus b? Remember that when we say we want to square a plus b, it means a plus b multiplied by a plus b again. So let's first imagine a square with sides a. Now let's imagine an even larger square with each side made up of two parts, a and b. If we divide the square, we get four smaller regions. One region has area a times a, another region has area a times b, another one has b times a, and lastly, b times b. We can label them as a square, ab, ba, and b square. Now, add up all the areas to get the total area of the square, which is a square plus ab plus ba plus b square. Since ab and ba are the same, we can combine them to get 2ab. That's the formula for the square of a plus b. Let's now see what happens when we square a minus b. The square of a minus b means that we are multiplying a minus b with a minus b. Just like before, picture a square where one part of the side is a and the other part is b, but this time we're subtracting b instead of adding it. When we multiply everything out, we still get four areas. A times a gives us a square, which is the area of the whole square. A times b gives ab, b times a gives ba, and b times b gives b square. Also note that a minus b times a minus b is equal to a minus b square. So let's combine all these parts to get a square minus ab minus ba plus b square. Since ab and ba are the same, we can once again merge them to get minus 2ab. So this is the final expression for the square of a minus b. Now, let's take a look at another important pattern, the difference of two squares. We are finding out what a square minus b square means. Imagine a large square with area a square and a smaller square of area b square cut out from one corner. If we were to cut the small square b square out of the big one, the remaining shape, which is this L shape, can be rearranged into a rectangle with the rectangle sides being a minus b and a plus b. So the total area left, which is a square minus b square, actually equals to a plus b multiplied by a minus b. This will make things more clear. So a square minus b square would be a multiplied by a minus b and b multiplied by a minus b. So when we simplify it, we would get a plus b multiplied by a minus b. That's why we call this the identity of the difference of two squares. Here's a summary of the three expansion techniques we just covered. Take a screenshot or write this down in your notebook so you don't forget it. Now, we will look at some example questions for the different techniques we just learned. Let's first look at the square of 3x plus 2y. Note that in this case, 3x equals to a and 2y equals to b. Looking at the identity we just learned, we will expand the square of 3x plus 2y. So we will first do the square of 3x, then we will multiply 2 with 3x and 2y, and then we will get the square of 2y. This will give us the final answer 9x squared plus 12xy plus 4y squared after we have expanded and simplified. Here's an example for the second expansion technique. Note that in this case m equals to a and 5n equals to b. Using the expansion technique we learned, we will now expand the square of m minus 5n to obtain m squared minus 10mn plus 25n squared. Now, let's take a look at example 3 where we will make use of the property a squared minus b squared. Note that in this case, 7p equals to a and 4q equals to b. Using the expansion property we learned, we will multiply 7p plus 4q with 7p minus 4q to obtain 49p squared and negative 16q squared.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.